Hello guys, welcome back. So in this video I'm going to explain you a couple of programmings. Okay, the first thing I'm going to explain how to find the average. Okay, it may be a little fast, but try to understand because we should not consume more time, right? So include a library file and write a main method inside which how to find an average. We need to find an average in such a way that we need to add two numbers and divide those numbers by how many numbers you have added. That's it, right? If you have 44 and 45, if you need to find an average, 44 plus 45 divided by 2, isn't it? That's the correct way, right? So what the user needs to enter first printf how many numbers you want to enter. Okay, this would be printed and we need to scan that, right? Scanf %d comma ampersand, it's not already ampersand yet. Okay, so we need to declare an integer of a. Okay, and the next thing we need to print, write in a new line, please enter the numbers you want to find average. Okay, and write in a new line, and we need to scan those numbers. How to scan it? We need to scan it inside an array, right? Okay, what is the size of an array? Array size would be a, isn't it? Because the user is entering a number of numbers, so we need an array of a, and every time we need to scan that, so we need a for loop for int I equals 0, I less than how much? A, the size of an array, I plus plus, and we need to scan those, right? Scanf %d comma ampersand, in which we need to scan it in array of how much? 0 1 2 3, so 1. Okay, I, so array of I. We need to find the sum for this array. Okay, how to find a sum? Declare a sum. Okay, int declare a sum with float. Okay, float sum equals 0, suppose. Every time we need to add that sum equals sum plus array of I. So instead of writing sum equal to sum plus, we can directly enter sum plus equals, right? So sum plus equals array of I. The next thing we need to do, we found the sum here. I'm going to explain the logic, don't worry, but try to understand where I am writing. Okay, it's very simple logic. Okay, so the next thing I need to do, I need to divide the sum by the number of numbers the user entered. Okay, and that would be a float value, isn't it? Float average equals, what's the sum plus, divided by how many numbers? A number of numbers, isn't it? So I'm going to print the value. Printf %f comma, what's the %f? AVG, right? Average we need to print. So I'm going to print like the average for the entered numbers is %f. So I'm going to compile this so that I can see if there is any error. Yeah, there is an error. What is the error? It's saying before int. Okay, we have forget to keep the semicolon at the printf value. Again, try to compile, and we are having another thing. We have forget to keep it here. Let me compile. So I'm going to enter 3. Okay, how many numbers you want to enter? 3 numbers. Please enter the numbers you want to find average. 12, 45, 65. So the average is 40.666668. Okay, 40.6 basically. Okay, it's also giving appropriate value. Okay, so 12, 45, 65, the average is 40.6. You can calculate it using your own calculators. This is the correct average only. And yeah, what's the logic? See how many numbers you want to enter. This will be printed in the output screen, and it will scan a number. Okay, and it will again ask the user, please enter the numbers you want to find the average. Okay, these numbers need to be stored in the arrays. Why? Because array is a simple form to store a same types of data types. Okay, so it's a easy way to find, to store. Okay, if we declare it, if this is the kind of situation, and for that we are declaring how many numbers the user enters. The user enters a number of numbers from 0 to a minus 1. Okay, we can give I less than a, or we can also give I less than or equals a minus 1. Both are the same thing. Okay, so instead of getting it more complicated, I'll always write I less than a, and every time it's incrementing here. Okay, and then I'm going to scan it. So every time I'm going to scan, every time the user enters a value, I'm going to scan it here under the array. Okay, and then we need to find the sum. Okay, so I have initialized the sum value as 0, and I am every time adding the array values. So what will happen here? Sum equals 0 first, and if the user enters 2 value, a number called 2, then what will happen here? 0 plus 2 would be 2, so the sum would be 2. Then if the user enters 4 again, so the sum is 2, right? 2 plus 4 here. Okay, what is 2 plus 4? 2 plus 4 would be 6, so the sum would be 6. And if the user again enters 6, so sum equals sum plus 6. What is the sum? 6 plus 6, 12. So it will increment in such a way, it will get the sum in such a way, and finally we are going to divide the sum with the given numbers. So this is how we find the average. So you can find the average for any number of numbers. I want to enter 6 values. Okay, see, you can find simply any number of values you want. The average is 128.1666626. That's it. So you can find it by entering how many numbers you want to enter. Okay, so this is about how to find the average. So next thing is how to find whether a number is a prime number or not. Okay, this is also a very important programming. So I'm going to delete everything, and I'm going to write check whether the entered number is prime prime or not. Okay, so what is the first thing we need to do? We need to include the library files, and we need to write a main function in which I'm going to declare an integer. Okay, integer n, and I'll ask the user to enter a number. Enter a number, sorry, to find its prime or not. Okay, and we need to scan that number. Scanf. What I'm going to scan it as ampersand n, since I have declared already here. So basically, what is a prime number? Prime number is a number which is divisible by 1 and itself. That's it. It should not divisible by any other number. That's it. So what I'm going to do, I'm going to write a for loop here. See what logic I'm writing. Okay, for int I equals 0, I less than n divided by 2. Okay, I less than equals, and I'm going to pre-increment it plus plus I. Okay, and what I'm going to do, if n percentage, so this will give us the remainder, right? The percentage symbol will give us the remainder, equals 0. What happens now? I'm going to declare a flag. Okay, an integer of flag equals 0. Simple. So I'm going to print this flag as 1. Okay, I'm going to mark this flag as 1. Okay, and it's going to break the loop. Okay, so whenever the flag turns to 1, it will immediately break the loop. Okay, And the next thing we need to do after writing the if and for, go out and write if n equals 1. Okay, so if n equals 1, what will you print? If if the entered value is an 1, so it is not a prime number and also not a composite number. Okay, it's the special type of number, so print like it's not a prime nor a composite, because if the number is 1, then it is not a prime number as well as it's not a composite number. So the next else, okay, I'm going to write under else. If it is not a prime, if it is not n equals 1, else if flag equals 0. Okay, if the flag is 0, print what we need to print. We need to print the entered value is, I mean percentage d is a prime number, isn't it? What is this percentage d? Percentage d is nothing but this entered number. I'm sorry, I need to keep a comma here. Scan n, okay, n. So the entered number is prime number. If the flag is 1, simply keep it like else. What we need to print? We need to print it is a prime number. I mean it's not a prime number. Printf print. I have missed t. Printf percentage d is not a prime number. Okay, comma, what is the percentage d? N. And let me check whether it works or not. Here I have missed a comma. Let me compile this. If I enter a 3, enter, it's not showing any output. Why? Because you can see here, why isn't it going to, okay, for int I equals 2, okay, it's not 0, I equals 2. Okay, so I'm keeping the flag as 1, and also if it's 0 equals 0, then I'm going to print this. Okay, if n equals 1 and flag equals 0. Now let us check. I'm going to enter 4. 4 is not a prime number. Okay, see the error I have done here. What I have done, I have entered the I equals 0. Okay, so that is the error. Every time I'm going to divide the 0, it's not even 0, it's 0 divided by anything is infinite, and the compiler is getting a little bit confused. Okay, so I have entered 2. I'll explain the logic, don't worry guys. Enter a number called 3. 3 is a prime number. Enter a number called 1. 1 is neither prime nor composite, right? 1, it's not a prime nor a composite. Let me enter a value 120, which is not a prime number. Okay, 120 is not a prime number. What about anything like 7, 13, 21, 13? Let me enter 13. 13 is a prime number. So you can enter any number and it tells me whether the entered number is a prime number or not. So how have I written? First, I am printing a statement to enter a number, and then I am scanning that number under an integer called n. Okay, so what's happening now? Every time for int I equals 2, I'm starting from 2 and less than half. Okay, so I am dividing the number by 2. You know, if the number if it is not divided by a number less than half of its size, if it does not divide by any of the number less than half of its size, it will not gets divided by any of the number greater than half of its size. Okay, it's simple mathematics which we guys will learn in our childhood itself. Okay, how to find a prime number. We can check up to the half of the length of that number. Okay, For 12, it's enough to check up to 6. Okay. For 20, it's enough to check up to 10. And if you enter 100, it's enough to check up to 50. If it's 120, it's enough to check up to 60. So by 2. So that's why I have divided it by 2. And I'm starting it with 2. Okay. So every number is divisible by 1, right? So 1 and itself, right? So I'm entering the value from 2. And I'm going to divide each and every number. Okay. I'm going to divide it with each and every number, and I'm checking it whether the remainder is 0 or not. Okay, if the remainder is not 0, it's well and good. If the remainder is 0, okay, if the remainder is 0, I'm firstly declared the value of flag as 0. I'm converting that flag to 1. Okay, if the remainder is not 0, it's well and good. It will continue in the loop. If the remainder is 0, I'm turning that flag to 1 and I'm breaking out of the loop. Okay, out of the whole loop, and I'm entering to the next if statement. If the entered number is 1, it is directly printing this statement. Okay, then there is no issue. Else, if the flag is 0, okay, if the flag is not converted till the end of the loop, it will print that is a prime number. If the flag is 1, when will the flag will become 1? If any of the number gets divided and the remainder is 0, then the flag will be 1. If the flag is 1, we are printing like it's not a prime number. If the value is not 1, we are printing like it's a prime number. It's a very simple logic, guys. If you know what is a prime number, then this logic is nothing. It is not only this, there is no only one way to find the prime number. To write any logic, there are n number of ways. If you get any logic, you can write in that way. Okay, it's simple. You need to get a logic. There is no one correct answer. Okay, in programming there are n number of answers. You may think in a different way so that you can write a different programming. Okay, different kind of style. You may have, every human has an unique style. You may think differently, I may think differently. Okay, I have thought to find the prime numbers in this way. You may think it in some other way, and you may write in such a way. Okay, so you may have another logic, so that is not a mistake. Okay, you can try it in your own way, but this is one of the best way to write according to me. Okay, so we have seen how to find an average and also seen how to find a prime number. Okay guys, so let us meet in the next lecture. I hope you enjoyed this video. Thanks for watching.